Before we look at today's lesson, we're going to look at this homework problem here. And we want to find the least common multiple between x squared minus 25 and x minus 5. Now x squared minus 25 will factor. But factor, well, x squared and 25 are both perfect squares. So we have x and x, 5 and 5, then we'd have plus and minus. X minus 5 is already factored, yes? So least common multiple. So there's two ways we can look at it. One is we see how many of each factor each one has and put those together. So x squared minus 25 has 1x plus 5. There's none on the other, so we need at least one x plus 5, yes? X minus 5, we have 1 here and 1 here, so each one has, so B. And that's it. So even though they both share really the x minus 5, the least common multiple is going to be x plus 5 times x minus 5. We'd have one of each. Because that one is a little tricky because the whole other term is already listed in the other one. So it seems a little weird, but that's really it. Any other questions over the homework? Now, what we're looking at today are simplifying complex fractions. And when we talk about complex fractions, we're talking about having fractions inside of fractions. So we'll have fractions in the numerator and denominator that we have to simplify out because we cannot leave a fraction in a fraction. It'd be the same as saying 7/3 over 1/3. We don't leave fractions in fractions. Now, with this example here, it's kind of nice because we can say 7/3 over 1/3 and tell us the answer is 7. It'll simplify it for us. We don't have to do anything with that there. Yeah. Now, unfortunately, we can't necessarily do it with the ones we'll look at today because of variables. Variables are a little bit trickier. We can't just plug those into the calculator. Now, there's two methods for doing this here, method 1 and method 2. We'll go through both and I have a feeling there's only one of these two methods that you're actually going to want to use. The other, we'll do it once and then that's probably going to be about it. So, method 1, if you want to, you can watch us go through and kind of pay attention along how we do this first time and then follow along with the second method. Because the first method, what we're going to do is get the numerator and denominator to be a single fraction. So the denominator here is 2, the numerator is already 1, so that's fine. So the numerator is fine as is. But we need to make the denominator into a single term. And to do that, we need to add them. And for us to be able to add the two together, we need the denominators to be the same. So for our 1 over x plus 4, we're going to have to multiply top and bottom by x. For our 2 over x, we're going to have to multiply top and bottom by x plus 4. And if we do this here, well, 1 times x is x. The denominator is going to be x times x plus 4. Our other fraction, the denominator is going to be x times x plus 4. The numerator, we're going to have to multiply through by 2. Well, 2 times x is 2x. 2 times 4 is going to be plus 8. Now that we have this here, we can add the denominators together. So we're going to have x plus 2x plus 8 over x times x plus 4. Well, we can simplify that. Scroll up this a little bit. because the numerator is still going to be 5 over x plus 4. And the denominator, x plus 2x is plus 8 over x times x plus 4. So we did all this to get it so that we have one fraction on top and bottom. Now, realistically, having two fractions is just the same as saying the numerator is being divided by the denominator. Is really all this is saying, 5 over x plus 4 all over 3x plus 8 over x times x plus 4. It's just saying we're dividing these two fractions. So to simplify this here, well, now we're doing division. So we keep the first, change it from division to multiplication, and flip the second. Now we can multiply these together. Well, if I can write this correctly, because that shouldn't be 8. That should be a 4. Well, the x plus 4 and x plus 4 will cancel out, leaving us with 5x over 3x plus 8. Questions on this here? It's not a difficult thing. There's a lot of steps, different things we're having to do: add, subtract, put them together, do division for all this here. Now, some of it could probably have been spaced a little better, but we do get to this here. Now, the second method. So my first main question is, what would happen if I multiplied this top fraction by x plus 4? What would happen with these two here? They'd cancel, yes? Okay. What happens if I multiply this fraction here by x plus 4? They'd cancel. And this here, 2 over x, if I multiplied it by x, they would cancel. And really what we're looking at is the least common multiple, our least common denominator. If we can find that, essentially what we can multiply the whole thing by, top and bottom, so that all the fractions will cancel out. We'll multiply the whole thing by it. So we can do x plus 4 on top and bottom, and x. Because whenever we multiply the top and bottom by, each one by, we need to do it to the whole thing. So we're really looking for what terms, numbers or expressions, can we multiply everything on top and bottom by so that all the fractions in the numerator and denominator will cancel out. And for us here, that's x times x plus 4. And that's the second method. That's the key to the second method here, is multiplying the top of the fraction and the bottom of the fraction by something that will make every single fraction on top and bottom cancel out. And when we do this, we multiply it with the numerators. So the x times x plus 4 is being multiplied by 5. So we'd have 5 times x plus 4 over x plus 4. And what do we know about the x plus 4 and x plus 4? They will cancel. We can do the same thing with the denominators, because we can do x times x plus 4 times 1, which is just x times x plus 4. And this is all over x plus 4. Well, we know that the x plus 4 and x plus 4 will cancel out. Plus, now we're going to have 2 times x plus 4 plus 2 times x plus 4. I'm just rewriting it so I have a little more space. And that's over x. And here the x, yes. X will cancel out. So in the numerator, what is the only thing we have left? 5x. In the denominator, our first fraction, all we have left is x plus times x plus 4. So in one move of multiplication, we've really simplified the fractions out completely except for our main rational expression, yes? Because we don't have any more fractions in the top, we don't have any more fractions in the bottom, we just have our single fraction. Now, yes, this does not look like the answer we got on doing method 1, but we still need to simplify. Because in bottom, we still have this here, we need to distribute the 2. So we have x plus 2 times x is 2x. 2 times 4 is plus 8. Combine like terms gives us 3x plus 8. And that is exactly what we got for method 1, yes? I think I know the answer to this question already. Which method do y'all like better, 1 or 2? 2, yeah. In the 8 years I've been teaching, I've not found a group that's really liked method 1 over method 2. Because method 2 is so much easier compared to method 1. Any other questions on this here? We ready for the next one? So I'm going to go on and ask it anyways. Do we want to do this by method 1 or method 2? 2. So we need to see what we're going to multiply the top and bottom of this by to get everything to simplify out. Yes, so we'll need an x minus 2 on top and bottom, and we'll also need an x. Do I need the x minus 2 twice? Because there's 2 of them, aren't there? There's one on top, one on bottom. Because each one of them only has, so we only need it once. Even though it shows up in multiple places, the only reason we would need it more than once is if it showed up in one of these more than once. Because if we had at the top x minus 2 squared, then I'm going to need to have it twice. Does that make sense? And any of these that we multiply over what is needed will get factored out at the end. So it's just adding an extra. I think we did in here the example with the 2 fractions where we used, I think it was 3 and 5. Saw that if we went too high, it came back out. I think we did that the other day. But that's also been, feels like a week ago, even though it was just Tuesday. All right. Now at this point here, we can multiply it out. So we multiply the top. 6 times our x times x minus 2. Which should be over x minus 2. We can do the same thing with the denominator, x times x minus 2 multiplied by 1. This is going to be x times x minus 2 over x minus 2. Plus, then we're going to multiply this with the 3. We'll have 3 times x minus 2 over x. 2 will cancel. This 2. And then x and. So the numerator, all we're left with is x, 6x. The denominator we're left with plus 3 times x minus 2. Yep. Now we do need to multiply out. 3 times x is plus 3x. 3 times negative 2 is minus 6. 6x over 4x minus 6. Is there any greatest common factors? 2. We can factor 2 out of the bottom, which tells us that we have 6x over 2 times 2x minus 3. 6 over 2 reduces to 3x over 2x minus 3. And that is as simplified as it gets. It would be very tempting to simplify the 3x and 2x, but we can't do that because the 2x, that minus 3, is a whole term. Because we can do it with multiplication here, we can simplify it. Because realistically what we're saying is that I have 6 over 2 times x over 2x minus 3. We essentially separate it with multiplication. 6 over 2 reduces to 3 times our x over 2x minus 3, which multiplies back in. Does that make sense? Essentially, when we just do those crossing out, we're thinking of it as split multiplication. 1 becomes 1 and goes back together. Does that make sense? Yes, or just agree? Yeah. Because all we did was split it apart. 6 over 2 is 3. 3 multiplies back with the numerator, giving us 3x. Any questions over this here so far? Now this one here is a little bit different because this is the first one we had where we had 2 fractions on top and bottom. And also the denominators in the fractions on top and bottom are in a set of parentheses. We don't have 2 terms added or subtracted. But that's fine. For this here, we're still looking for the least common denominator. We're still looking for what number we need to multiply the top and bottom so each of the fractions will cancel out. So we're trying to see what is the first number I can turn 3, 6, 5, and 10 into? 30. 30. And we can look at the multiples of 3, 6, 5, and 10. But really, what's the first number that 3 and 6 both go into, or we can turn both into? 6. 5 and 10 is 10. So we're not really looking at all 4. We're just looking at 6 and 10, which is 30. Now we can multiply the whole thing, each one of these, by 30. So 30 times x over 6 is going to be 30x over 6 minus 30x over 3. We'll do the same thing with the denominators, which will give us 30x over 5 minus 30 times 7 is? What's 3 times 7?
21, 200.
Yep. Yep. Yeah, especially with 30s, any 30, 20, any of those, 10s, 100s, just take the first number and multiply it by whatever it is, add the zeros. Now we need to divide. 30 divided by 6 is, we have our x, minus 30 divided by 3 is 10x. 30x divided by 5 is x, minus 21. 210 divided by 10 is 21. Now we do need to simplify a little bit because 5x minus 10x is negative 5x. Can we combine 6x and 21? Do they have a greatest common factor? It is. Because we can factor 3 out of 6x, giving us 2x minus 7. Now at this point here, 5 over 3 will reduce to 5 over 3. It doesn't reduce. Yes? And I said that intentionally because at this point we've gotten probably in the habit of something factored out, then it reduces and we move on. But it's not always going to. Here the 5 over 3 doesn't reduce, so that's the answer. Now, I put this in here intentionally because it's good to see that we still can factor something out and it not reduce. but it's still good to go on and continue to do that just in case it might. And we would give this as the answer. Really, this is it. Now, there's other ones we can look at, because if we feel comfortable with this here is, because this here, what would we multiply top and bottom by? Just x. Here we would do x plus 5 and x minus 3 and simplify out. I want to look at this one here, because we can get some of these that are quote unquote harder. But the principles and properties that we're doing aren't any different. It's just we're adding steps. We're going to have to do more steps and simplify. Because in top and bottom, on top, how many fractions do we have in the numerator? 1. Yes? How many do we have in the denominator? So what would we need to multiply top and bottom to get that one fraction to go away? And that's all we have to multiply top and bottom by, because we don't have to worry about the x or the -4 or the x and 3, because they are already integers. They're already whole numbers. We don't have a rational, they're not even rational, they're just expressions. We don't have a denominator. So the main one we're focused on is the last one. So once we get this, we're going to multiply all 3 terms by it. So our first one is going to be x times 2x plus 3 minus 4 times 2x plus 3 plus, what's our last one going to be? Because we're going to do 9 times 2x plus 3 over, it'd be 9 times 2x plus 3 over 2x plus 3, which is just what? Now, I say that because if we see that those cancel out nicely, it's just 9, it's one number left over, that's fine. Now, if you do find it helpful to write it out, especially like this here, and then say, okay, these here cancel, do that. There's nothing wrong with that. And for this here, it's not bad. To just cancel it out, we're good. All the ones we've done today, we could have just simplified as we went and been fine. We'll look at one more, and some of the ones after this, especially I think the one not immediately after, but the one after that, it's good to write them all out, just so we make sure we cancel it out correctly. The denominator is going to be x times 2x plus 3 times 2x plus 3 minus 5 times 2x plus 3 over 2x plus 3. But we know these will cancel. So we could have just written -5 or -5 without having to write that out. Either one works. Now at this point here, we can start simplifying. Distributing x times 2x is 2x squared. X times 3 is plus 3x. -4 times 2x is going to be -8x. And -4 times 3 is -12. Plus 9. The denominator, we can do the same thing. X times 2x is 2x squared. X times 3 is plus 3x. 3 times 2x is plus 6x, and 3 times 3 is plus 9, and then we have -5. Combine like terms. Well, 2x squared, really on top and bottom, is the only term. It can't just cancel out, unfortunately, because 3x minus 8x is -5x. Since we still have addition subtraction, they're stuck together. -12 minus 9 is negative 3. 3x plus 6x is plus, and 9 minus 5 is. Since we do have this addition and subtraction, those terms are more or less stuck together, because we can only really start crossing things out is if the 2 on top are being multiplied, the terms on top are multiplied, terms on bottom are multiplied, and something's in common there. Now, we can see if this factors. Now, for the numerator, since the 3 is negative, our signs are opposite. If the third term's negative, our signs are opposite. If the third term's positive, the signs are the same and match the sign of the middle term. 2x squared, well, our factors are x and x. Factors of 2 are 2 and 1. Where do we want to put the 2? Right here. Factors of 3 are 1 and 3. Where do we want to put the 3? By the negative, and we can put the 1 with the 2x. Now we can check this to make sure that this does work. 2x times negative 3 is negative 6x. 1 times x is plus x, which gives us is negative 5x. Is that what we wanted? Okay. Let's see if the denominator will factor. Since the 4 is positive, the signs are the same and match the sign of the middle term. Plus and plus. 2x and the reason we chose 1 and 4 is because if we have 1, we have 2x plus 1 and 2x plus 1, yes? We get something in common on top and bottom. Now, it's still going to be good to check to make sure, for one reason, because as we've already seen on one of the homework assignments, we factored both and there was no common factor. So it's good to just check. 2x times 4 is 8x. 1 times x is going to be plus x. And 8x plus x is positive 9x. That is our middle term, yes? So 2x plus 1 and 2x plus 1 will, leaving us with so I think y'all would agree with the statement that this problem here did look harder than the ones we've done previous, yes? But it was just the same thing, yes? Because the only thing we really added was more terms we had to simplify, more things we had to multiply together to simplify out. Any other questions on this here? Out of these last 3, which one do y'all want to look at?
That one looks like it should just, they should just all cancel out. But the one above that with the square. Yeah, that one.
This one?
That one.
And if you are curious with the next one, I did do it third hour. So third hour's video will have it posted with it. And if we do have time, I will go through it here also. But we'll see. Now, each of the denominators for this here are monomial terms, yes? So looking at the top, we do have a y squared, and we have an x squared, and we also have xy to the first power, yes? So x, we know we'll need an x on top and bottom. We'll also need a y on top and bottom, yes? But do they need to be to an exponent? So let's see. So if we multiply these out, so if we do xy times the first one, we're going to get xy times 1 is just xy over y squared. Will the y over y squared simplify? Well, they will, but we'll have what? A y left over on bottom. So, okay. So if I square the y, so it'd be xy squared. Those y squared over y squared will cancel, yes? Minus 1 times xy squared will give us xy squared over xy. So these here would cancel out completely, yes? X would cancel out, one of the y's would cancel out, so we're good here, yes? So we can say this cancels out with one of these, and this would cancel out completely. Minus 2x y squared over x squared. Will the x's simplify out completely? No. So the y's will, well, we need what? X squared, y squared. Because since it's individual terms, x is to the second power, so we'll need at least 2 for each one, x squared, y squared. Well, that means this is squared, and this is squared. And for here, x squared will simplify. 1 and 1. So I'm going to finish writing out the numerator, then we'll do the denominator here in a second. So what are we left with in the first term? Just x squared, yes? Minus xy minus 2y squared. The denominator, so xy, x squared, y squared, is going to be over y squared minus 3 x squared, y squared over xy plus 2 x squared, y squared over x squared. And for the denominator, the y squared and y squared will cancel. Here, the x squared and x squared cancels, and xy cancels with one of the xy's, which tells us that we have x squared minus 3xy plus 2y squared. Now, these here actually do factor. Since we have x squared, x, middle term, y squared, they do actually have a set of factors, interestingly enough. So sign, let's do sign first. Since the third term, 2y squared, is negative, the signs are opposite. Positive and negative. X and x. We will have y and y. So we can try this here. X times negative 2y is negative 2xy, yes? And y times x is going to be plus xy, which gives us a negative, which we wanted, yes? Since the third term is positive, the signs are the same, and they match the sign of the middle term, so negative and negative. There's x squared r, x and x. Right, y, and then we just need to pick one of them to be 2. And if we check this here, x times negative 2y is negative 2xy. Negative y times x is negative xy, which gives us negative 3xy. Now we do have something in common on top and bottom. These here will cancel, telling us that we have x plus y over x. That's final answer. Questions on this here? Not as bad as y'all thought that was going to be. Yeah. And again, even with the next one, this here, there are a lot of terms to it. But the process and what we're doing doesn't change. It's the same type process. It's just a lot of simplifying and canceling things out. But unfortunately, they won't cancel each other out. Here, I don't know why they decided to do this here, but this is the same as x plus 1. 1 plus x, x plus 1 are the exact same thing. Let's get this here. This is the exact same thing. And if we were wanting to do this here, we'd have to multiply top and bottom by x plus 1 squared and x minus 1 squared. So here we'd have x plus 1 cubed times x minus 1 over x minus 1. Now I'm going to be, how are we doing? Yeah, since we're running short on time, this here is the same as negative x minus 1, but the negative and negative would make a plus. Now we have x minus 1 cubed times x minus plus 1 squared, because the first one needs, x minus 1 needs to be squared too, because we're multiplying both of them by squares. Now this is going to be over x plus 1. We do the same thing to the denominator. X minus 1 squared times x plus 1 squared over x plus 1 squared plus x plus 1 squared times x minus 1 squared over x minus 1 squared. Now in this here, x plus 1 squared, x plus 1 squared cancel. X minus 1 squared, x minus 1 squared cancels. So what that leaves us with on bottom is x minus 1 squared plus x plus 1 squared. We have this here. The numerator, x minus 1 will cancel out with one of those. X plus 1 will cancel out with one of those there. Which leaves us with x plus 1 cubed times x minus 1 plus x minus 1 cubed times x plus 1. Kind of makes sense on this so far. Yes? Now, we're going to have to multiply these out. And again, I'm doing this mainly for time's sake. I'm going to skip a step and multiplying x plus 1 by itself 3 times. If we do x plus 1 by itself 3 times, we get x cubed plus 3x squared plus 3x plus 1. If we do x minus 3 squared, it's going to be x cubed minus 3x squared plus 3x minus 1. It's more that I've had these almost memorized, kind of how the pattern works. X squared, x minus 1 squared is going to be x squared minus 2x plus 1, and this here is going to be x squared plus 2x plus 1. Realistically, all we're doing is multiplying these together. X minus 1 times x minus 1, x plus 1 times x plus 1. We're doing it multiple times. So it's not changing the process. It does look daunting, but it's just multiplying them by each other multiple times. Now the numerator, to finish this out, we have x cubed times x, which is x to the 4th. X cubed times negative 1 is negative x cubed. 3x times x is plus 3x cubed minus 3x squared. 3x times x is going to be plus 3x squared. 3x times negative 1 is negative 3x. And 1 times negative 1 is negative 1. Plus x cubed times x is x to the 4th. X cubed times 1 is plus, plus x cubed. Negative 3x squared times x is negative 3x cubed. Negative 3x times 1, negative 3x squared. 3x times x is plus 3x squared. Sure. Yes. 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 Yep. 3x squared. And then 3x times 1 is plus 3x. Negative 1 times x is negative x minus 1. Now the denominators, negative 2x canceled. But 2x, x squared plus x squared is 2x squared plus 2. Yeah. And that's how it ends up getting with some of these here. Now, yeah. Here, negative x cubed cancels. Negative 3x cubed, negative 3x cubed cancels. 3x squared cancel. Negative 3x squared cancels. Negative 3x cancel. Yep, and I think I'm missing a term somewhere here. 3x. Yeah, there should be a plus x here, which plus x and plus x cancels, leaving us with 2x to the fourth minus 2 over 2x squared plus 2, which here we can factor the 2 out. X to the fourth minus 1 over 2 times x squared plus 1. Funny enough, those cancel, telling us that that's kind of frustrating, isn't it? That all of this became that. Yes. There's your assignment, by the way. So.